Firstly, thank you very much for having me. It's a great honor to be presenting at a university with so much Antarctic research going on. And special thanks to Daniela for organizing my visit, particularly while she's on sabbatical, or meant to be on sabbatical, this term. So I'm in New Zealand. I'm based in Fort Collins in the United States. It's nice and warm and summery up there at the moment. So being an Antarctic historian, I wanted to come down into the middle of winter. So I'm a little disappointed by the weather today. It's a little on the warm side. But I'm spending a few weeks traveling around New Zealand and doing some research for this project on the history of the McMurdo dry valleys. So I'm really looking forward to be able to talk to you about this and hopefully to get some of your ideas and insights into this project. So in terms of Antarctic history, one of the big themes recently or I guess for a little while now, has been how scientific was the heroic era of Antarctic exploration. And we have people like Ed Larson and his fairly recent book, An Empire of Ice, which makes a case that the heroic era was very scientific and science was the main goal, rather than just being an excuse for adventure. Well, I think this is an interesting topic and worthwhile to look at. What I'm trying to do is turn this question on its head. And instead of asking how scientific was the heroic era, asking how the history of the heroic era can contribute to contemporary science. So sort of flipping that around. And my location for doing it, the McMurdo Dry Valleys, I think offers an ideal site for this sort of project. So many of you, probably all of you, will have some idea. This is more for my US audiences, where you have to explain the Arctic and Antarctica, North and South, and all that. But the McMurdo Dry Valleys, very close to Ross Island and Scott Base. This is a closer view. The two main valleys, Taylor Valley and Wright Valley. Probably I'll be talking a little bit more about Taylor Valley or Taylor's Valley today, and just a sort of a satellite image of the landscape here. So a fairly unique environment in Antarctica, in a place covered in ice. This is the largest ice-free region on the continent. It's a good place for thinking about the integration of ecology and science for two reasons. Firstly, it's been a place that has really been a center for scientific research, at least since the 1950s, and I would suggest perhaps even longer. And then secondly, we have a pretty good record, although Daniela and I were talking just before the presentation this evening, it's not quite as good as it maybe could be, of what people have been doing in different places in the valleys at different times. So it's a useful place for putting these things together. So what I would like to do over the next few minutes is to give a little bit of a background about how I came to be thinking about history and ecology in the dry valleys, a little bit about the long-term ecological research project that is taking place there. Then I want to take an example from the early expeditions from Griffith Taylor in particular, who spent a week in the Dry Valley in February 1911, and use this sort of as a case study for starting to think about how history can inform scientific research. And then I want to say a little bit about the work I'm doing on this trip and bringing the story closer to the present with the more modern history of Antarctica since the IGY. So the first person to set foot and sight the dry valleys was actually Captain Scott in December 1903. He was coming off the polar plateau, and he discovered this, what he wrote about as a curious valley in his report of the expedition, the Discovery Expedition, and famously noted that it is worthy of record that we have seen no living thing, not even a moss or a lichen. It is certainly a valley of the dead. Even the great glacier which once pushed through it has withered away. And this is a wonderful irony, given that the dry valleys have become a center point for ecological and biological research. But this was sort of the first impression. I actually prefer William Lashley, who was with Scott, described it as a great place for growing spuds, which was a little bit more practical. And as we'll see at the end, some people have taken that literally. So Scott was there in 1903. As part of the Shackleton expedition, Shackleton really wanted to go and explore the dry valleys. He was thinking that this might be a place where they could find valuable minerals or such like. But as it turned out, Raymond Priestley, who was meant to spend a couple of weeks exploring the dry valleys, could only spend about 24 hours there at the very bottom around New Harbor. Then in 1911, as I mentioned, this guy, Griffith Taylor, who's become one of my heroes of Antarctic research, spent a full week going up and down the what is now Taylor Valley, and that's no coincidence. You might have spotted the name. He did everything possible to make sure that Taylor Valley was named after him. So we'll come back to Taylor and his expedition. After this, there was no interest in no human presence in the dry valleys until the International Geophysical Year. This is an expedition. This is actually the second Victoria University of Wellington expedition that went down during the IGY. The two people on the left, Barry McKelvey and Peter Webb, they'd actually gone down as undergraduate students the year before. Apparently, the story goes, they'd seen the American planes flying overhead in Wellington and had asked if they could go down to Antarctica. And back in those days, they simply said, yeah, why not? We'll give you a place on the plane. So they started to pioneer research in the late 1950s. And since then, this has been a site of constant scientific activity. Every season since the late 1950s, scientists have been there doing research. And this is a typical landscape in the McMurdo dry valleys. This is Lake Bonny. You get some sense of why it's become a focal point for scientific research just from the image. Geologists clearly like it because you can see the rocks. You don't have to dig through a kilometer of ice to get to the rocks. Geomorphologists like it because you can understand the glacial action and looking at moraines and the history of ice in the region. This is Lake Bonny. It's a frozen lake. So it's actually a center for limnologists and the study of Antarctic lakes. There are also streams. The longest river, they call it, in Antarctica, the Onyx River, 32 kilometers long, runs through Wright Valley. So this is an interesting place for doing hydrology. And then in these soils that Scott thought were completely barren, it turns out there are nematodes and these sort of microscopic ecosystems living in the soils and in the lakes and in the streams. And so it's also a place for biological research. And one of the things I've been looking at fairly recently is in the 1960s in particular, NASA was very interested in the dry valleys because it was seen to be an analog for Mars. And many of the spaceflight ideas were tested, at least conceptually, in places like Taylor Valley and Wright Valley. In the early 1990s, the United States National Science Foundation established a long-term ecological research site in the dry valleys as part of its nationwide network of long-term research sites. And this gives you an overview of the locations of these places. You'll notice they're pretty much all domestic, apart from Moorea, which is in Tahiti, and then the two sites in Antarctica. And we can speculate and maybe discuss at the end about some of the political motivations for this. But McMurdo and Palmer are the two Antarctic LTER sites. The LTER network has an interesting history in itself. It emerged out of the International Biological Program of the 1960s and 70s, which was sort of the biologists' answer to the IGY, the International Geophysical Year, which played such a prominent role in the history of Antarctica. So laying the groundwork in many ways for the Antarctic Treaty of 1959. The IBP was this sort of big science meets biology, and attempts to really model the natural world, understand systematically all of the processes. And it had sort of mixed results. But one outcome of the IBP was that the LTR network was established to continue this long-term monitoring. And it sort of makes sense that if you want to understand ecological change over time, you have to be in for the long haul. You have to be constantly monitoring and seeing how things are changing, not just for a couple of seasons, which is the average length of a biological project, but over decades, and I think they would say even centuries. So the early 1990s saw the expansion into these end member ecosystems, these extreme environments where you can really test things, ecological theory in a landscape that is extreme. And so this is just a stream gauge running into Lake Chad and Lake Hoare here. And the biologists are measuring the water flow. They're also measuring algae and all sorts of biological life to try and understand the connections between the physical environment and the biological environment. The LTR network at a similar time also started expanding into cities and urban areas. And there was a really an interesting realization in the 1990s and in the early 2000s that if we really want to understand ecological change on planet Earth today, we need to understand human interaction, human impact on the environment. So there's actually two cities, Baltimore and Phoenix, are part of the LTR network. And it sort of fits with this notion of the Anthropocene and the ideas that all environments have been touched in some way or another by human presence and human activities. So about 6 years ago, when the LTR network works on a 6-year renewal cycle. So every 6 years, the sites are up for renewal. 6 years ago, there was a mandate came from above that said every single site needs to have some sort of human dimensions research in the ecology of it. And this is easy for a place like Baltimore, obviously. But for somewhere like the McMurdo Dry Valleys, it's a little trickier to think about how would you integrate human dimensions into this. So I found myself in the right place at the right time, Colorado State University, as an environmental historian. I'd just written my doctoral dissertation on the history of the Antarctic Peninsula. So I put my hand up and said, this could be an interesting challenge to think about ecology and history in this location. And it's sort of been really fun to talk to people working on really human impacted places and then think about that in relation to Antarctica. One of the motivations for ecological research in the dry valleys is this sense of simplicity, the idea that you can really test complex ecological theory in a place that doesn't have quite so many variables. And I've taken this and suggested that it's also useful, we can take this historically and say that the simplicity of the human history, with relatively few people going down there, a very short chronology going back only as far as 1903, helps us really to understand what I would call the environmental history triangle. And as environmental historians, we try to understand the interrelationships of human activity, human perceptions, and the material environment over time. And it looks very simple when you put it up on the whiteboard or the projector like this. But very quickly, these interactions get incredibly complicated and difficult to untangle. So my argument, and I'm not sure if it fully holds, is that we can think about these things more clearly in the dry valleys than some other places. And then in terms of thinking about how history can inform the science, one of the things we're most interested in, at least in terms of the past, is what was the material environment like back in 1911 or back in 1903. So we can start thinking about ecological change over time. So this can then inform our own understanding of the environment and environmental change and how this is happening. So you sort of put these two triangles together and you get some sense of what we're trying to do. So moving on to my sort of case study of, let's look at the Taylor expedition and ask how it can inform contemporary ecological research. So the main hypothesis of the McMurdo 4 grant, which we're currently in at the moment, is that climate warming in the McMurdo Dry Valley ecosystem will amplify connectivity among landscape units, leading to enhanced coupling of nutrient cycles across landscapes and increased biodiversity and productivity within the ecosystem. And that's a handful or a mouthful for a historian to say. We don't normally say things like that. But this is the sort of this is what is driving the research that the scientists are doing in the region at the moment. One of the things that is, one of the observations, this sort of graph is only possible through long-term monitoring. So these are the streams going into Lake Frixell, and each color is a different stream and how much water is flowing through it, and then put them together and you get the overall stream flow for the season. And what you see immediately is this 2001-2002 flood year, this epic event that maybe some of the people in the audience were actually down in the dry valleys and experienced this. But there was massive glacial. The streams are fed by melting off the glaciers, and then it runs through the streams into the lakes, and the lake levels rise based on the melting. So we have this incredible. We had during the 1990s a period of climatic cooling, which also saw a nice sort of correlation between lowering stream flow. Then all of a sudden there's a spike, and then since that spike, it's gone sort of not crazy, but it's a new system is in effect. And one of the interesting things that we've noticed is that since the 2001-2002 flood year, the stream flow no longer connects directly to the temperatures. So in fact, the annual temperatures, which is the dotted blue line on the graph, have in fact continued to fall slightly over the last 10 years, but stream flow, as you can see, has continued. So there is a number of possible explanations for this, and these are just three explanations that we've talked about and have been sort of driving the thinking of the ecologists in the LTER site and in discussions internationally as well. So one idea is that it's not so much temperature that affects the melting, it's about sunlight and this notion of a bombardment of energy, that it's solar radiation, so you can measure temperature, but that doesn't tell you that much about melting ice. So that's one explanation. A second possible explanation, is that there were intense winds in the 2001 winter, which might have blown increasing amounts of sediment onto the glaciers, and then this caused increased melting because of the dark sediments warms faster than ice, and so increases the melting, which would also explain the ongoing high flow seasons after that. And then a third possible explanation, is connected to the ozone over Antarctica and the increase in UV radiation based on the position of the ozone hole over the continent. And we're doing a lot of work trying to correlate this connection to the UV. So is melting taking place when the ozone hole is directly over the dry valleys? So those are some, and there's probably other explanations as well, and the reality is probably some combination of different ones of these. But I think these questions give us a great opportunity just to sort of play with the idea that history has a role to play in thinking about these explanations. So we're going to jump back now to 1911, February 1911, the first week of February 1911, and these four men, Griffith Taylor, Charles Wright, Evans, and Frank Debenham, went into the dry valleys and spent a week going up and down the region. In fact, just thinking back quickly, one of the reasons I've got such an affection for Taylor is he was this wonderful sketcher, wonderful artist. He was always doodling, always producing these beautiful images. Some were more cartoon-like. Others were this sort of really, you don't get the full effect of this, but this watercolor map of the region. And it shows the route that they took up from Butter Point, up the Farrar Glacier, down what Taylor insisted was a separate glacier and should bear his name, into the Taylor Valley, this dry valley here, which is where they spent the 7 days, going up and down, sketching. Unfortunately, cameras used to weigh a lot more, and the photographic plates used to be very heavy. And when they got off the glacier, they all of a sudden had to carry all their belongings. So they decided that they would only take with them 6 photographic plates on the walk because they didn't want to carry the extra weight. So we only have 6 photographs. But we have descriptions, sketches, as I've said, little maps like this. And then they went back the other way up and along over there. So it was sort of a really interesting expedition on a number of for a number of reasons. There's good social history involved. If you're interested in the heroic era, there was sort of a class difference going on with Evans as the naval recruit, and then the other 3 scientists clearly felt themselves socially superior. Griffith Taylor had these wonderful dreams as he was, and he reported all of his dreams in his diaries, and he was being chased and shot at and all sorts of things, which probably says a lot about his mentality. One of my favorite things, they tried to pan for gold in Lake Chad, and as you can see from the quotation, they didn't find gold, which is one of those classic what ifs. What would have happened if they had found traces of gold back in 1911? You can imagine sort of the Klondike gold rush transferred down to the dry valleys and how different Antarctica would look today, but they didn't find any of this. They sang a lot of songs. It was fun. One of the challenges for historians is we have to sort of untangle the speculation, or not the speculation, but Debenham, Charles Wright, and Taylor were all scientists. And so every time they saw something, they would try and explain it. They were trying to make sense of the natural world. And so you have to sort of read through some of their explanations. So for example, blood falls. Taylor believed that this was the staining, the red staining on blood falls was caused by algae in the ice, rather than the iron deposits that I think are now believed to be causing this. So you sort of read between the lines and to get a sense of what the environment was actually like 100 or so, 105 years ago. This is interesting, and I got very excited to start with, that this is Taylor's published map of the region. It was published in 1913, so almost immediately upon his return. Everybody was excited about this expedition. Captain Scott had just died. There was a lot of publicity. They rushed to publication. And on the map, if you know the valleys, you'll notice that this is where this lake, this is the modern image, Lake Frixell, should be in between Canada and Commonwealth glaciers. And he completely left it off the map. So when I first saw this, I thought, well, maybe this lake didn't exist 100 years ago. And it's been caused by the melting that we know to have happened since then. This sadly wasn't the case. It was just an error of an error. And it also shows that Debenham and Taylor maybe weren't speaking to each other as much as they should have been immediately afterwards. But what we do know from these early expeditions is that the lake levels have risen fairly extraordinarily over the last 100 years. So this is a sketch map of Lake Bonny drawn by Frank Debenham, and this is the contemporary modern image, satellite image of the same lake. And this also gives us maybe a sort of a sense of the problems of translating historical data into modern scientific data. Clearly we can't make that many inferences from the sketch map, but there's also a sense that you can see it's expanded. You can get a sense of the expansion of that. And this is where, quite incredibly, Captain Scott in 1903, coming off the glacier, got to this place here called the Narrows. And for some reason, he decided to measure the width of this area. And he measured that as 17 feet and recorded it in his diary. So this has given us sort of a baseline which we've gone back to, and the 17 feet down here is now significantly, I should have checked the exact numbers, but a couple of 100 meters or so, let's say. And we can use that to say that the lake has risen by about 16 meters since 1903, based on this measurement. And just a sort of a visual image of this, this was the looking back at Taylor Glacier in February 1911, and they re-photographed, they tried to recreate the exact photograph 100 years later, and just sort of flicking forward and backwards a little bit. It's not perfect, but we get some sense, a clear sense of lake level rise. And these are the images, or these are measurements that we've taken. So this is Scott's 17 feet. Taylor actually, I think he said it was about 100 feet wide. So significantly larger. So that it had gone up fairly dramatically just in the few years between 1903 and 1911. And then this is when we've got a systematic record going up, going down again in the 1990s slightly, and then going up again. But we're looking at sort of 14, 15 meters of lake level rise over a 100-year period, which is significant in many ways. And it's not just Lake Bonney that is rising, Lake Hoare, Lake Frixell, and Lake Bonney in the Taylor Basin, and of course Lake Vanda has risen, and the Vanda station that I'll show in a few minutes had to be moved or removed because of lake level rise. So other ideas of this, this is Lake Frixell in the background, the value of rephotography. We can see it from a picture that was taken from Andrews Ridge, and then see the same, which is expanded somewhat. And this is another example of a sketch map, and I should have shown the photograph from the other direction, but this clearly shows that the lake is not touching the Canada glacier. Today the lake abuts the glacier itself and is directly in contact with the glacier. So things are changing fairly dramatically. So just quickly going back to these three questions and how do we explain what is taking place after the 2001, 2002 flood year and the explanations. So the first explanation, this idea of the increased energy, the sunlight and so on, this is very difficult to get a sense of directly from the records. As many of you will know, it takes, I think, usually it's said to be 30 years of daily weather records will then create climate. So all we have is this snapshot, 4 days, 5 days, 7 days in the valleys. And if you look at the little notes at the bottom, they didn't trust their thermometers. That they worried it was so warm that the thermometers had broken. So it's really, we don't know exactly where the temperature would be. I attempted to average these temperatures out and put it on this chart for all of the modern temperature records. And so this is where it's high, not as high as potentially it could have been, but it's away from the average, and it's feasible that this is what they were getting, but potentially the thermometer was broken, and we don't know exactly. But I think that the most important thing in terms of this one, this explanation, is that Taylor also reported crossing a number of these meltwater streams, and some of them had a significant amount of water still in them in early February, which is the time when the streams are starting to slow down and stop. He drew a map of the streams in the Frixell Basin. On this map, he remembered to put the lake back on the map. But from everything I can tell, based on the temperatures, based on the rapid rise in the lake level since Captain Scott, this was a period of increased connectivity. This was a time when things were moving, when there was clearly a lot of energy in the system. And related to what we're seeing today, this raises interesting questions about, is this sort of flood year and its aftermath, is it unique, this sort of pulse event, or has it happened before in the dry valleys? And what I would suggest from the historical record is that potentially the pulse events leading to changes, fairly dramatic changes, we do have precedent for them. We don't know if they were quite as extreme as what we're seeing, but this suggests that the the sort of the lake level rise might have gone up, stabilized again, and sort of more of a terraced system than a slow sort of pressing rise over time. Moving on to the question, the idea of wind. And again, the history doesn't answer the questions, but it brings some interesting perspectives into this. And so I love the weather records, the damn cold for drawing, bitter wind, beastly cold, very windy, unpleasant day, very windy all day. So it was windy when they were in the dry valleys, and these sort of strong winds are nothing new. The idea of the sedimentation on glaciers that we're proposing or thinking about as a cause of increased melting, again, this sort of repeat photography of the Seuss Glacier, it's impossible from these images to really get a sense to quantify how much sediment we're seeing on the glaciers. But you can clearly see in 1911 that there was sediment there. There was plenty of sediment on the glaciers causing melting. Whether it's more or less than 2014 is impossible to say, but it shows it's not a binary. It shows that we've got this constant sedimentation, and how much additional would a winter of wind produce. And then finally, this idea of the ozone hole and UV radiation responsible for the melting. So this, the hole, of course, is constantly fluctuating, moving, and so sometimes it's more intense over the dry valleys, other times it's less intense. And there's an attempt to look at this data and put it alongside the glacial or the stream flow records, and they're finding, I think, quite a strong degree of correlation. But what Taylor does, and this takes it back in time to the first half of the 20th century, a period where I would suggest we're seeing something similar to these intense melting events that we've seen recently. But this is a time before the CFC, the commercial production of CFC. So we have the first half of the 20th century with no CFC production, and so presumably the ozone layer was significantly smaller than it is today. And so the history suggests that it doesn't mean that it's not a result, that the contemporary melting isn't a result of the ozone, but we need to account for early 20th century melting in a way that doesn't necessarily rely on UV radiation. And another possibility, and I don't know if this is at all realistic, is that we can maybe read through ecological changes in ozone levels over the dry valleys looking back. So I would suggest that none of these things are perfect. The history is simply raising some additional questions, engaging with some of the scientific thought, but is clearly offering a perspective. And I would suggest that this perspective is really worth thinking about and exploring as much as we can. So just moving quickly on to what I'm doing at the moment. So what I'm trying to do now is to move the story of the dry valleys forward in time into the modern scientific era. And this is, some of you might have been down to the University of Waikato, or I guess up to the University of Waikato in Hamilton. This picture is on the Earth Sciences wall, and it's of John McCraw and Graham Claridge in the 1959-1960 season, where they had this wonderful packing case that they'd hauled across the McMurdo Sound, and they used this to cook in and to do some of the scientific measurements in. And I actually got to interview them, and they told me that it wasn't them that wrote the vote Labour on the packing case, that this had been someone back at Scott Base. But then the red flag is flying, so I don't know. Another issue with historical sources. So I'm trying to put together information from a variety of different sources, and there's a really interesting history of science in the valleys since the late 1950s, which New Zealand and the United States really are the two central characters in this story. Some of the work I've been doing has been archival research. So in Christchurch, in particular, the National Archives here, and over at Antarctica, New Zealand, there are really good records of the end of season reports from Vander Station, meteorological reports from Vander Station. Up in Wellington, there are the sort of the policy documents that tell us why in the late 1960s New Zealand decided to take a lead and establish a station in the dry valleys. So archival research is a really important part of the project. Another thing I've been trying to do is to go back to, if we want to understand the history of science, some of the best records are the old scientific papers that were really trying to explore some of these ideas about why is there no ice and snow in the dry valleys. This was one of the first questions that people started to think about. The long-term onyx measurements, again, give us this insight, this sort of snapshot into a changing, some sort of climate change over the long term. These records began in the 1960s and have continued up to continuing up to the present. So this long-term record of measurements, and we can find this in the scientific papers. There's interesting and sometimes bitter debates about the stability of the East Antarctic ice sheet, which really focused on the dry valleys and what we can learn from the geology and the geomorphology of the dry valleys. A third source that I've been using is oral history interviews. So actually trying to talk to as many of the people who've been working in the valleys as possible. And at the weekend, I went up to the, I guess, Lake Hawaii and Alexandra and interviewed Trevor Chin, who was a hydrologist, glaciologist, scientist of all trades. But by talking to people, you get many of the stories that don't appear in the official reports in the archives or in the scientific papers. And so Trevor was telling me about the origin of the Asgard Rangers and the rivalry with the Vander Vandals that took place all around the Lake Vander hut. And there's this wonderful sort of social history of a culture developing in a place, in an extreme location. Some of you might be familiar with the Lake Vander swim club, which was popular. But this is an attack of the Asgard Rangers on the Vander hut, and they drew their little Rangers Viking helmet to show that they had conquered the hut. So that's another form of historical information that we're bringing into this. And then finally, one of the main things I've been doing recently is trying to collect together historical photographs of the region and organize them chronologically and spatially. So we have an easy record of what was taking place and where it was taking place. So this, for example, is a picture of it's a little confusing, but it's what the New Zealanders called the Frixel Camp. And in the early 1980s, Keith Thompson decided to put a greenhouse in the Frixel Camp and was trying to grow various tomatoes and lettuce and different things. And I thought this might have been a scientific experiment. I actually chatted to Keith a couple of weeks ago up in Hamilton, and he was saying, no, it really was just, basically they wanted to get the record for the furthest south grown vegetables anywhere. So it really had no scientific value. But importantly, the greenhouse was taken out. This area around Canada Stream was declared one of the 5 or 6 Antarctic specially protected areas within the Antarctic specially managed area of the dry valleys. And so today, if you come across this place, it looks more pristine, more protected than many of the surrounding regions. So having an idea that this sort of thing was taking place 30 years ago could inform what we're finding there today and some of the science. So we're putting this onto an online database. I won't try and get it up because I don't think the internet is working well, but this is sort of what it's looking like. And we're trying to put as much of many of the photographs into the database as possible, and then organize them through the sites of human occupation and through places like Lake Bonny, Lake Vander, and different glaciers and so on. So that you can click on one of these places and get a record, not just of the photographs, but of historical, the the interviews I've been doing, the historical archival documents I found. So this gives a really easy to use summary of each of these places and the history that is taking place or has taken place, which can be used by researchers. If you're going to measure Canada Stream, you might not know anything about this, but just a couple of clicks away, and you can find all of this information. So one of the things I'm particularly interested in is old photographs of the dry valleys to try and really populate this with as much information as possible. So I'll put my email address up in just a minute, and if you have, or please come and see me at the end if you know people, or if you have photographs of the dry valleys that you'd be happy to share with this project. So in conclusion, I think that particularly in terms of the modern historical research, one of the real values of this comes in terms of environmental management. That if we really want to understand how human activity has had an impact in the region, we need to be able to quantify that to some extent, say who was doing what, where were they doing it, and get some sense of the numbers of people. So this is the beginning stages of attempting to do that, and then we put that alongside some sort of environmental monitoring. We can get a sense of what kind of activities are harmful or change the environment, which other sorts of activities might be okay. So this is really important information from an environmental management perspective. But like the Taylor's data contributing to contemporary debates, many of these, much of this information can also contribute to the way we're thinking scientifically about this. So I would say that the dry valleys, the history is worth studying in the dry valleys, not just for its own sake, not just because this is an interesting history, but because it has value to the scientific work that's taking place there. And I think this is a model that can be used in other parts of Antarctica. I know Ursula is doing some work on historical weather data. A few other people in different places are trying to integrate history and ecology, but there's a lot more work that could be done to do this. And then I think what we do in Antarctica potentially has value in other parts of the world with more complex ecosystems and more complex histories. So I'd like to acknowledge National Science Foundation, the support staff, friends, and in particular everybody who's contributing to this project. That I'm coming to realize that historians, we tend to be very solitary creatures, and we like to go to the archive and not necessarily talk to many people. This is forcing me to engage with a lot of different people, different personalities. It's been an amazing experience to be part of a scientific team and think about the kind of collaboration that takes place. So I'm really grateful to everyone who's contributed photos and interviews and archival documents to the project. And then just my email address, if you do know of anyone who might have some useful photographs or data to contribute to this, please come and see me afterwards or send me an email, and I would love to hear from you. So thank you very much.